Okay, guys, so here's a little bit of a recap also on binomial and normal distribution. I'm not going to do any problems for this one. I just want to go ahead and lay out when do we use them, what to watch out for, and how to calculate the probabilities, right? Because I think I did a lot of problems in class, and there's videos on binomial and normal distribution. So just go ahead and look at those. But I just want to go ahead and lay out when do we use binomial and when do we use normal, right? So with binomial, a couple of things that you have to know is that binomials are always going to have this two outcomes, right? So make sure that in the problem, if you have two different outcomes, we're looking for the problem, and we have probability of success and trials, and they're all independent, then they're going to be a binomial distribution, right? This is how we write it. X is a distributed binomial with NP. N is the number of trials, and P is the probability of success. A binomial random variable also has a formula for the mean. It's just n times p. Okay, and the standard deviation, right, is square root of np 1 minus p. So what I would do is I would actually write all of this into my cheat sheet if you need to, if you know that you're going to forget it, right? So we know that whenever we use a binomial distribution, this is what we're going to use, okay? Now, right here, what I did, I kind of laid out the functions, right? So we are either going to use binomial PDF or binomial CDF in different forms. So I did kind of every single form here. Equal sign is just very self-explanatory. It's just binomial PDF. Now, the CDF can be a little bit difficult for most of you, right? So let's say if it was less than, so like these last two, well, it really depends, right? What I would suggest is whenever you see a problem, right, write it in probability notation, right? This equal sign means that I'm going to go ahead and have this 2 here. When it doesn't have an equal sign, it means that I'm going to go 1 less than this, okay? For binomial CDF, when it's greater than that, right, whenever you have greater than, then we're still going to do binomial CDF, but we're going to do 1 minus, right? Because binomial CDF can only do area to the left. Okay, so we're going to do 1 minus that. Remember that the sign switches, and then we also, if we have an equal sign here, then we get rid of this one. However, if we don't have an equal sign like in this one, then we're going to go ahead and add it over here. So it really depends on the nature of the problem. This is something that you guys are going to have to figure out on your own when you do the problem, and really write down. If you need to go ahead and write down the number line and see if 3 is included or not, then you have to be very, very careful with that. Okay. In the exam, I will not tell you if something is included or not. Okay. Notice that when something's not included, right? Like for example, this 3, I put it in blue. That we go 1 less because it's not including the 3. Okay. Now, with normal distribution, right, the problem itself will say it's normally distributed, right? So if you see this keyword, right, so this is a keyword. If the word says normally distributed, then this is what you're going to have to use, okay? Now, the mean is mu, standard deviation is sigma, right? There's no formulas for those. Those are going to be given to you. What I would suggest is draw the graph, like literally just draw it. And what I've been seeing when I'm grading your assignments is that a lot of you guys are not drawing the graph and you're getting it wrong. So please just go ahead and graph them because that will really, really help you, okay? One thing about this is that with binomial CDF, notice that you always went 1 down. For normal CDF, you don't go 1 down. This one it only is for normal and binomial. Okay, so I also wrote down here if I'm given the value. So if I give you a value, right? So let's say I give you the value of 3, right? And I want to find the area that's above it, right? This is what I want, right? The area, probability, percent or percentile. Then we're going to use normal CDF. Okay. If instead we're given the probability, area, percent or percentile, and we want the value, so instead I give you, I don't know what the value is, but I know what the area below it is, or the percentile or whatever, right? Then we use inverse normal. On the restriction that the area must be to the left. So for example, if I have something that looks like this, right, and my area instead is here, which is on the right, let's say this area was 0.2. Well, we can't get 0.2 because inverse norm says, hey, I can only get the area to the left. So what I'm going to do 1 minus, right? If this is 0.2, this thing should be 0.8. So 0.8 is what I'm going to write down on the area on inverse normal, okay? So that's the only thing I kind of wanted to lay out. I will go ahead and go and do examples on either Monday or Tuesday, whatever class you're in. I'll do more concrete examples, but I want you guys to be able to write all of this down so that you guys have it. And when you're practicing on your practice or whatever, literally try to follow these two guidelines. Okay.